wasn't gonna do a face live, but I was like, you know what? Let's do this. Um, I'm going live really quickly now, and then I wanna like exercise, shower, and then go live again with the full physics and astronomy topics. But I did wanna go live at this time right now while the sun is still up and it's daytime, and I can show you the snow. We got a ton of snow last night in Boston. I was a little bit feeling overwhelmed by it and some things, but at this time I feel really good. And here I am. And I feel good that I'm starting this live, and I will be live for a longer time today. I will do this live, then I will take a break, shower and all that, and then I will start my next live, which will be the more physics and astronomy topic. Ram Candy, how are you? So here is Suji Mama, and then are you ready to see the snow? Let me show you. So here is Suji, and look at all the snow. My goodness. See, look at that. Do you see the layers of snow on the picnic table? That's how you know how much it snowed here. And let me show. Here is Fuji Bablu. And here is Baji Bablu. Yay! Baji! Hi! Ram Candy says, wow, yes. Thank you. Welcome to the live. Welcome, welcome. How is everybody doing? I decided I wasn't quite ready to go live. Here's my baby. Here's my Fuji Baba. But I decided I'll do a live now, and then I'll do another live after my shower. So we are live. We're live, we're live, we're live. Here is the kitty cat, and here is Snow. Snow live and kitty cat live. Here we are. So let me do this. Let me... Oh, I just got a... Let me... 1 second. Let me put the phone right here. Bee, so cute. Thank you. Here is the kitty cat who is sleeping, and I'm gonna share the live, and I'm gonna show you the snow, and we're gonna chat and hang out and catch up for a bit, and then I will go shower and stuff like that, and then I will go live again. So that's the agenda. But look at the brilliant sun right now. We got so much snow last night. We got so much snow. And all of that is right there. And hi, Baji. Oh, Baji, there's something on your head. Ram Candy, anybody else who wants to say hi? Say hi. Hi. Hello. Baji says hi, and he closes his eye. Oh. Hi. Hey, don't give 2 pucks 18. Hello. Hi. Oh. And it's a holiday in the US, so I'm hoping that people can join and be merry and be happy. And there's the snow. Snow time, Baji time. So let me share the live with you here on my channel so that you know we went live. little Suji Mama. How is everybody doing? Tell us. Did anyone else get a lot of snow last night? Suji, you're so cutie. Suji's such a cutie. Hi. She's so cute. I love you so much. I love all my kids so much. She's so cute. Such a cutie. Look at this. It's a cute, cute neck. Cute throat. Oh, ho, 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 ho. Hi, Fuji. Fuji actually has a little booger. Let me get that. Let me get that. Okay. Should I... Fuji. I gave Fuji a kiss and he's mad at me. But Fuji, I'm looking for just boogers and things to remove from your face. He's acting like a dinosaur. Are you a dinosaur, Fuji? Are you a dinosaur? Look at Baji. He is not a dinosaur. He is mostly a sleepy baby. He's such a sleepy baby. Oh my gosh. Oh my gosh. Oh my gosh. Yay. Oh, look at this. Look at this little baby. A little belly. Little belly. Okay. I'm gonna put this down. We can chill for a bit. We can chill for a bit. And I could read something for you. So, I was thinking tonight, when I go live, I will... So I was covering the planets and interesting facts about the planets last night. And oh, that's right. The other thing that we haven't yet covered is small bodies in the solar system. That's another whole thing too that we might want to cover. And that would involve asteroids, trans-Neptunian objects, comets, meteoroids and dust, and I'll show you this really cool picture of an aerial view of the Barringer crater in northern Arizona. So we do have some craters on Earth. We talked about how many of the objects in our solar system are affected, of course, by impact craters. But some of them are paved over by volcanoes, volcanism. Hi, Clicker. Hello. Here, be like that. I can read your comments. Hello. So, finally, I am so. Let me read your comments. It's a very cold day here today. Lots of snow. But right now, there's also a lot of sun. So, it's kind of nice. It's kind of nice. It's really cold and really snowy. It was last night, that is. Not right now. It's sunny right now, but there's a ton of snow. Ton of snow everywhere. Okay. So, let's see. Clicker says, here, finally, I'm so sorry. I said I was going to be way earlier. Oh, that's okay. Anahi says, hi, I miss you. Oh, thank you, Anahi. How are you? How are you doing? Thank you. And how are you doing? Yay. Ooh, thank you for liking, by the way. Thank you for liking the live and thank you for subscribing. Yay. I'm actually preparing my notes and a promise. Oh, very nice. What's the promise, Anahi? I'm actually preparing my notes and materials for the physics and astronomy live tonight. So I'm actually I'm gonna eat something and do some exercises and then shower and then start this live early today so that I can go for a long time and we can talk about these topics for a long time. So I'm actually looking at my materials for that right now. So what we covered last night, if you're interested in getting a little recap, is we covered the solar system in perspective. And actually, so I was talking about the planets and sort of a planetology, a comparative planetology within our own solar system. So then we would be prepped and prepared for exoplanets, right? That was sort of the idea. And I started I started on that already. And we also looked at a lot of the individual planets more specifically and in depth, and also some of the moons, including our moon, as well as the other giant moons of the solar system. Turns out there are like 7 giant moons, and we actually have one of them. And then, of course, there are the Galilean moons of Jupiter, the ones that Galileo discovered, and they are also pretty giant. And how lots of interesting facts about those moons, as well as Titan, that's a moon of Saturn, and then also Triton, that's a moon of Neptune. So those moons we had also covered in the past and whatnot. So because some of these things we had covered in the past, we sort of reflected on them again last night. We covered them in bit more detail in the past over the course of a few different live streams. So hopefully I named those live streams somewhat specific to the information. Sometimes the live streams are a little bit generically named because I'm not exactly sure what I'll do. But then I get started on some topic and then that leads to other topics as well. But yeah, so the giant moons. Oh, I think I did have a live called Giant Moons, and basically what that was is the giant satellites in the solar system, including, so this is an exhaustive list, the planet, as well as which satellite. So our planet Earth, of course, has just the one moon, and it is one of the giant moons. Then we had Jupiter's giant moons, Io, Europa, Ganymede, and Callisto. These are also called the Galilean moons of Jupiter because Galileo discovered them, and they have historical significance as well because of that discovery. Then we had Saturn, the planet, and its giant moon, Titan, and then we had Neptune, the planet, and its giant moon, Triton. Now, of course, the Jovian planets or the Jupiter-like planets have a lot of moons, but these are the 7 really special ones because these are the biggest satellites of our solar system. So yeah. Anahi says, be beautiful. Hello, Baji's mom. Thank you. You're doing amazing. Are you a research physicist or you just have a PhD? I do have a PhD and I did work in multiple jobs as sort of a research scientist, analyst, systems analyst, those types of roles. Right now I'm focused on teaching here on YouTube, and I have some, I also write books, you know, things like that. And let's see, I'm looking at my channel as we speak, actually. Got distracted. So yeah, let me know any other questions you guys have. Thank you for being here. Thank you for attending the live. Welcome, welcome. But yeah, I'm just kind of mentally preparing to cover the topics today. So you're sort of seeing the preview of what's to come. So we covered the giant moons and also all the planets. We covered probably our own planet, the Earth, with the least amount of time. But pretty much we covered the planets. So once we saw a good coverage of these planets, we were kind of ready for a comparative planetology, which is what we're covering right now. And we made some really good progress on that last night. I was able to get through a lot of the material, and then because of even with understanding our own planets in our own solar system, that actually really prepares us well for exoplanets. So that's something we will look at next when we talk about this. So we will do the exoplanet detection. So I'm looking at it right now. Let's see. So yeah, it's one of the most active fields in astronomy is the study of exoplanets, or planets around other stars other than the sun. As more exoplanets are discovered, this is the statistical study of planetary systems will allow a better general understanding of how planets form and evolve and whether our own solar system is ordinary or anomalous. So that is actually something that people have thought about, which is that is our own solar system sort of a normal solar system, or is it an anomaly? Are we an anomaly where this particular environment that we, you know, have the privilege of being in and that supports life, including us, is that sort of a normal type of thing as far as planets go, as far as solar systems go, or is it pretty special? And you know, because if it's really special, then that might mean that there is not a chance, or there is a less chance of finding life on other planets and in other star systems. So those types of lines of thought is what is kind of motivating exoplanets and discovery of these other star systems, and also the understanding of what those star systems are. And because we have such a nice solar system ourselves, with quite a lot of variety and diversity in just even the planets that we have in this solar system, and not even that, even within a particular planet's system like Jupiter, Jupiter has so many moons, and depending on the distance from Jupiter, these moons are even very diverse and different from each other. And also gives us a model actually for a sort of a mini solar system in its own, where Jupiter is the warm object, which is outputting heat and energy. We talked about that too, that Jupiter is actually outputting quite a bit of energy, even though it's a planet. It's not a star, because to be a star, you'd have to do like nuclear reactions and be burning and fueling yourself with nuclear power, such as our sun is doing. Hydrogen to helium conversion, which is a nuclear physics reaction. So Jupiter is not quite doing that, but it has certain other things going on, which also makes it very warm. It's very massive, first of all, the most massive planet, 318 times the mass of the Earth. But also it has a couple other things going on, and we talked about that a few live streams ago. But so being a moon of Jupiter is really no joke. Depending on how close you are to Jupiter, your life will be very different, and the moon is very different. So Jupiter has over 60 moons. Someone asked me how many kitty cats I have, and I jokingly responded, well, that's like asking how many moons there are for Jupiter. You're always discovering another one. So the Galilean moons were, of course, discovered by Galileo back in the day. Very, very historically significant event in the history of science, because it showed that other planets also have satellites. We were not special. Earth and geocentric model is sort of off, in the sense that look at this other heavenly object or another planet also has satellites. And because he discovered the giant moons of Jupiter, of course, those are also more possible to discover. So, but depending on the closeness to Jupiter, so Io is the Galilean moon that's closest to Jupiter, it has a very different sort of composition and things going on with it than even the other Galilean moons of Jupiter. And this planetology topic that we covered last night was basically showing how, well, this also gives us a look into how solar systems form and how planets and satellites and suns, and it's like we have a solar system and we have a couple of mini solar systems even within our solar system, namely the Jupiter planet and its moons, for example, or even the other planets like Saturn and Uranus and Neptune and their moons, because these planets are so huge and warm compared to their moons. So we looked at that, and it was really interesting, I thought. So we said giant satellites of Jovian planets show patterns consistent with our ideas about formation of the planets. So, because formation of planets is very important, to understand when we try to understand other planets completely away from us and where there could be life, or there might have been life. So it's not that the life has to be contemporary with us. If there was once a time when there could have been life, then that too is very interesting. Such as there is some evidence, for example, of finding erosion by liquid water on Mars. So there could, in the past, have been some sort of liquid water and life there. And as you know, there are significant efforts to research things on Mars. We've sent the Mars rover. There is even a lot of conversation about, settling on Mars. So all of that comes from, these motivations, of course, that maybe it's possible, or maybe there was such a thing happening. Maybe there was some sort of life on Mars. So even understanding the history or evolution or formation is important as well. So the satellite systems surrounding the Jovian planets formed in a process that mirrored that of the solar system as a whole, with a central massive warm object surrounded by an orbiting disk of material. The inner satellites of Jovian planets, Io and Europa, for instance, formed under relatively warmer conditions than the outer satellites, Ganymede and Callisto, for instance. The higher densities of the inner satellites imply a higher fraction of dense refractory rock and a lower fraction of low density volatile ice. So, as you know, the moons that are closer to Jupiter, they are experiencing a much more hotter climate. And so the stuff that will make up those moons is going to be materials that are able to condensate uh, at a higher temperature, and the moons that are farther away will be made up of more volatile materials that um, basically would otherwise evaporate away at cooler temperatures. Inner satellites show evidence of volcanism driven by tidal heating in this case and resurfacing. So that's another thing too. The inner planets experience Jupiter's gravitation more extremely, and Jupiter literally makes Io, the moon that's closest, the Galilean moon that's closest to Jupiter, have immense and extreme tides, where even the insides of Io are under these tidal forces. And indeed, Io is a very active volcano site. So lots of volcanism happen on Io, lots of volcanic eruptions, which constantly, of course, change its surface and things like that. So you're going to find less craters on Io because all the volcanoes have paved over them, whereas you might find craters on other moons of Jupiter. In the solar system, the largest planets, Jupiter and Saturn, formed in the middle of the system. So that's the other thing. In our own solar system, Jupiter and Saturn are really big, right? So huge planets, and they formed kind of in the middle of the system. So the rocky planets are kind of closer to the sun. Then Jupiter and Saturn are kind of towards the middle of the solar system. And things like Neptune and Uranus are farther away. So just like in the solar system, the largest planets, Jupiter and Saturn, formed in the middle of the system, where there was a favorable trade-off between temperature, cool enough for volatiles to condense, and density, high enough to make massive bodies. Similarly, in the satellite systems of the Jovian planets, the largest satellites formed in the middle of the system, Jupiter's Ganymede, Saturn's Titan, and Uranus's Titania. So Ganymede is the largest moon of Jupiter, and it too is sort of in the middle of the Jupiter system. Whereas same thing with Saturn's Titan, which is the largest moon of Saturn, and same thing with Titania, which is the largest moon of Uranus. So these bigger satellites seem to form sort of in the middle, where there's a good trade-off between temperature and density. And what do you know? The same thing applies to planets. The biggest planets in our solar system, Jupiter and Saturn, are sort of towards the middle of the system from the sun. Again, where there's a good trade-off between temperature and density. So this type of thing is super interesting. We talked about this type of thing a lot, comparative planetology. So we will kind of take off from there. Oh, wow. I see your comments. Hi Anahi, I see your emojis. Thank you. Big B, Mad Hatter. Oh hi, thank you. Mad Hatter says you're very special. Thank you. Anahi sends a lot of emojis. Very nice. Big B says good, Mr. Kitty. Jupiter has 60-ish moons. Yes, Jupiter has over 60 moons. Mad Hatter says, love it. Combat Sport says, do you think the cat understands why Jupiter was not enough big to initiate nuclear fusion between hydrogen nucleus? Yeah, so Jupiter is really big, but it does not have a nuclear reactor in its core. It does have a ton of hydrogen, though. It does. It has a very big metallic hydrogen layer that we have talked about, actually. It is very unique in that sense, where it has such a huge metallic hydrogen layer, where it is both massive enough and its central pressure is high enough where it allows hydrogen to exist in its metallic form, liquid metal form, but it does not in fact have a nuclear reactor like the sun does. So the sun is actually doing nuclear fusion of hydrogen and making helium. Jupiter does not do that. I think Suji gets that, right? Suji mama? Did you watch The Presidents? I did not. He promised a manned Mars mission under Elon's. Okay. Checking in. Can't stay for the live feed, but we'll watch the on-demand video later. Ajay says Doro here. He's not here yet. Take care, guys. Thank you. Yes, I'm good. I'm good. How are you? I'm just giving you guys a preview. I'm gonna go live, and I need to eat some food and work out a bit and then shower. I wanted to go live. This is a little early. I wanted to go live and show you the snow and things like that. So that's why I went live early right now, and then I'll go live again like I normally do. I'm preparing for my university exams, which happens in 6 hours. So at 8 o'clock, good luck. All the best for your look at the snow. That's what I wanted to show you, the snow, the sun, and the kitty cats in the sun. So that's why I went live early to do that. And then I will do a few things and go live again. Baji Papa. Little Baji. Oh, such a good boy. Baji is such a good boy. What's the temperature? I don't know. I think it's supposed to be like 15 degrees Fahrenheit today. Something like that. It's very cold. So yeah. Okay, so after talking about that, let me do my notes. I'm gonna talk about exoplanets today, so I'm preparing. This is the live before the live. It's the live before the live. Okay. So, detecting planets around other stars is far more difficult than detecting planets orbiting the sun. Neptune was discovered when it was close to opposition. So I think we will talk about some of the challenges of discovering the exoplanets, which of course, the stars, we spoke briefly about. Even the closest stars other than the sun are really quite far away. And so detecting planets that are around these other stars is no joke. Oh, cool. I was checking your old videos, and the oldest is from... Yeah, I can talk about my academic journey. Sure. Yeah, I basically have a blog. It's called howtophd.org/blog, or I think even just howtophd.org should work. But I have a number of blogs on the PhD journey and how to get one, how to finish one. I have a book as well, actually. I have a few books on it as well on Amazon if you want to check them out. But all of the information is also on my blog. So feel free. But at some point I should talk about my things here as well. Indeed. Yeah. Thank you. Yes, indeed I can. What is your... let me know if you have any specific questions, like which field you're in, what are you thinking? Are you thinking about like getting a master's, a PhD, and whatnot? I can try to answer it. Okay, happy studying and good luck. I'm studying too, actually. I'm looking at the exoplanet discovery material and trying to see at what level I want to cover it in the live. Direct imaging of exoplanets is difficult. Planet searches have so far concentrated on indirect methods of finding exoplanets. Thank you. For instance, the existence of a dim exoplanet can be deduced from its gravitational effect on its parent star. So there we go. Gravitation. Okay. Yeah, thank you. See you soon. Center mass is closer to the more massive object. To return example, mass of Jupiter is. Okay. Making some notes here. Hmm. All right. The exoplanets are going to be really interesting. I kind of knew already, but I just confirmed that there is some very surprising, startling results with exoplanets. So we will cover that. Thank you for liking the live. Appreciate it. We're just doing a relaxed live. I'm doing a little bit of preparation for the live tonight. So hang out with us while it's still sunny. And we will be back online or back on live in another hour or so as well. Ooh, yes. Standard candles. Stellar remnants, we covered this already. Hello. The US is going to Mars. Okay. Didn't we do that already? Ooh, can I get one more like? Can I get 10 likes, please? This is just the preview live of the live Doro. So get ready. I'm just preparing my thoughts for the physics live tonight. The meeting before the meeting, that's what this is. How's the work going? Oh, please like the live, please. Thank you. And subscribe. Okay, well, we're gonna be doing a longer live. I'm gonna start my live earlier and go for a longer time. That's my plan anyway. Okay. I need to take some notes actually. exoplanets. Morphology. Properties is the one. Then oh, Fuji's playing with my diary. Oh, really? Get the big bucks and big numbers by talking about the inauguration speech all night. Who, me? I haven't even watched the inauguration speech. I'm busy reading about astronomy. I did a phone call. I had some chores, did that, and now I'm reading about astronomy. And then I will work out. And then I will shower. I'm not gonna probably watch the inauguration speech. I don't know if there is anything new there. Page 426. Can we get 10 likes, please? Get the big bucks. So, look at that. Isn't that a pretty picture? We're going to talk about this today. Nova and supernova. So, Nova V1500 Cygni during its outburst and after its outburst, when it had dimmed. Nova V1500 Cygni. How interesting. Science rules. But what happened earlier was wild. Then again, I'm fascinated by everything crazy like that. What happened earlier as in the speech, you mean? I generally live under a rock, so you can tell me the news. Because I don't really know. I don't really know, to be honest. Okay, so we're going to cover nova and supernova. Cataclysmic variable. I think one of my favorite words is cataclysmic and Venusian. Ooh, that's right. Our galaxy, morphology of our galaxy. Kinematics and dynamics of our galaxy. What? Oh my gosh. Oh, that's right. I talked about dark matter candidates. Oh my gosh. I talked about dark matter candidates from this part already. First candidate was neutrino, next candidate was WIMP, weakly interacting massive particle. They're still looking for that. Third candidate was macho, massive compact halo object. Wow, I've covered this already. Goodness gracious me. You'd have to watch it, but if that's not your thing, I get it. Oh, we'd have to watch the inauguration speech. Can you summarize for me? What was the most interesting thing that happened? Is it the Mars thing? That we're going to Mars? Is that what happened? Most interesting. Nucleus of our galaxy. At the distance of the galactic center, an angle of 1 arcsecond corresponds to a length of 1,000 astronomical units. Oh my gosh. Magellanic spiral. Supermassive black holes. You know what? I'm getting distracted. Sometimes I get distracted by even me and what I'm reading. How is that even a thing? I'm getting distracted. I need to make the list of the things I will cover, and that's the task I'm doing right now. Nova and supernova. Okay, that's done. And then we'll talk about our galaxy. Our galaxy. Hi, Fuji baby. You're such a cutie. Fuji's a cutie. Fuji's the best baby ever. Hi, baby. I love you. I love you, Fuji. I love you, Fuji. Okay, our galaxy, page 433. I'll keep my thoughts out of it. Fine. Ooh, we will talk about globular clusters. In the late 18th century, our galaxy is shaped like a grindstone. For those of you who haven't recently sharpened any knives the old-fashioned way, a grindstone is a thick disc made of coarse, abrasive stone. Unfortunately, the Herschels were unaware of the existence of interstellar dust and didn't take into account extinction by dust. As a result, they came to the erroneous conclusion that we are near the center of a relatively small galaxy. The notch in the grindstone, shown on the left side of figure 19.2, is actually the result of a dust lane down the center of the Milky Way. Oh my god. I love our galaxy so much. It's so nice. Quarter of the stream will be by James talking about which of his mom's clothing he's wearing. I'm serious though. You guys have encouraged him too much. You and Reese are to blame for that James Goodlife person talking constantly about his mother's clothing. I wanted him to have a safe space to say what he wants to, but then he doesn't really contribute to the live in any other way. And it's a very one-sided type of connection that he has developed with this live stream, where he comes, he says what he has to say, and then that's it. And you guys just go nuts over him. It's extremely unequal. And I don't like that this person is called James, because I like the name James. And this James is not a good James, this mother's clothing James. And he just has to come to my life. Unbelievable. Unbelievable. Does he even understand English? Does he understand English? Mm. Unbelievable tomfoolery takes place as soon as he comes. 12 giga-years. Typical ages estimated for globular clusters are 12 giga-years. Our galaxy has about 150 globular clusters associated with it. The nearest globular cluster is M4, which is about 2 kiloparsecs away from us. The most distant of our galaxy's globular clusters is 100 kiloparsecs away. Wow. Hi, YT. Hi, Toya. Hello. Gave him the safe space that you wanted, and I'm happy to do so. Welcome to Philippines. Hello, everybody. Yeah, it became unsafe for me though. I'm like, he's derailing my stuff. I'll just not look at the comments when he comes in because it's highly distracting. It's highly distracting. When he comes into the live, it becomes highly distracting for my ADHD brain. But you know what? I'm going to exercise before my live so that, well, I usually do, but today I'm going to do it at home. Okay. Oh, look at this. Look at this picture. We're gonna talk about this. The Milky Way seen from Mount Graham, Arizona. Welcome to Philippines and welcome to my life. Ha ha ha. Thank you. Welcome to Philippines, as in I want all of Philippines to attend my live now, please. Toya, and we will be going live again today. But look at this, it's so pretty. It's so pretty. And look at this. This is the cross section through the Herschel's grindstone model of our galaxy. It is so pretty. So pretty. So pretty. Pretty, pretty. It's not distracting. You would attend his class if you taught one. Thank you for liking the live. Thank you. Well, then he should teach one. He should. He should teach one. The Orion Nebula, the local hot bed of star formation, is situated within the Orion Spur. Look at that. Wow. Nucleus of our galaxy. Sana All Student College. Okay. Thank you so much for coming to the live. Please do like the live. Thank ya. The Hubble Ultra Deep Field is the result of 800 exposures of a single field in the constellation Fornax, with the Hubble Space Telescope summing to a total exposure of over 11 days. Well, he'll be there, Doro. I graduated senior high school and I have work. Very nice. Thank you for liking the live. Thank you, Toya. Thank you, Doro. You want to attend my live and also attend James's live. Got it. And yes, he will have things to say. He usually comes in around 1 in the morning, talks about what he will wear, and then he's done. So if you're around at 1 in the morning, probably will come across him. Okay, bye. Bye, Toya. See you next time. I'm going to work now. Have a good day. Work properly. And as in, I hope work is good for you. And have a nice time. Galaxy classification. That's right. Oh my gosh. I do like galaxy classification. It's so funny to hear you describe him. Oh, it pains me. Is it funny? It is my authentic experience of this guy. It's my authentic experience. Work hard, play hard. Yes! Good luck. My authentic experience of this guy is he comes in at 1 in the morning, he dresses, and he talks about that, and then he goes to work probably and focuses on his life while he has wreaked havoc in others. Active Galaxies. It's pretty funny. It's pretty funny. Okay, you know what? We'll do clusters and superclusters a different day. I think we will end with morphology of our galaxy, page 433, 434, 435. We'll talk about the Herschels. Indeed, we will talk about the Herschels. Herschel. So stupid. He has to tell you what he's wearing. He just simply has to. Types of active galaxies: Seyfert galaxies, quasars, radio galaxies. Man, can't wait to, now that I look at the Active Galaxies chapter, I can't wait to talk about the Active Galaxies as well. They're quite different. Quasars, probing the intergalactic medium, clusters and superclusters, when galaxies collide. I came here for cats, then I began getting physics lessons, and now I watch English people go at it in the chat. Oh yeah, seriously, Doro, I don't know if you knew this. Maybe I've mentioned it in the past, but basically my viewership, like the audience of this channel, is first of all, the most people are US people, American people, and the next biggest population of viewers is the UK people. So, and I think after that might be, sometimes it's like Germany, sometimes it's Australia. It's not India. I thought that the most people after US would be India, but it's not. It's UK, and then Germany or Australia, and then, so yeah. If you want to see the British people fighting, chances are it will happen in my live. Apparently, they come here to spill their deep, dark secrets about what they want to wear, not talk about physics, but be there during a physics live stream, create a volatile environment, reminding us all of Neptune and Uranus and their moons, let's just say, I suppose. So, Steven, hello. Hi, Steven. Hey, all, cute kitty. Yes. This is the preparation for the main live, so thank you for coming. And please do come to the main live as well. And a few of us have been kind of chatting and stuff, but yeah, that's what this is. Good to see you, Steven. Oh my gosh, Steven, did you see how much snow I got? It's in the beginning of this live. I showed all the snow. We got a lot of snow. And it's going to be extremely cold for a few days, like 2 degrees Fahrenheit. The Indian see James and what he's talking about, and they bail. The Indians see James and what he's talking about, and they bail. Yeah, I think James has been repelling all of the Indian people. I know, they come in, they see what the chat is, you guys and your, blasphemous chat, and then they're like, okay, no, this is not for us. Just came on moments ago. So, these freaking British people just downing my business. So at some point, I think maybe tomorrow, we might talk about galaxies colliding, worlds colliding. Oh, wow. Our snow from a while ago had melted, but now we got a ton more. Yeah. Basic cosmological observations. Hot Big Bang model. You got nothing? Been watching the news on the inauguration all day today. That is all I'm saying. Good, get it out of your system. We will go live again soon, and I'm not going to be covering the inauguration, that's for sure. I mean, just because I don't even know what happened, I didn't watch it, and I'm reading about astronomy. Yeah, we got nothing. Been watching the news on the inauguration all day today, that is all I'm saying. Wow, no snow yet down there, huh? Down in Virginia town. Do not want to start a political debate on here. This is as far as I will go. Will not say whom I voted for in November. Sounds good. I mean, who people vote for is sort of private, isn't it? Like, isn't it supposed to be just keep it to yourself? Keep it to thyself. So guess what? I realized that the big crunch, some people were asking about the big crunch, and some of that is actually covered in this book. I'm enjoying watching people react to the inauguration, though. True there, Doro. I'm American, but respect everyone I meet until they hurt me in some way. That's good. Aw. Hopefully nobody hurts you. Astronomical data. Maki dwarf planet. I just want to chill and have a laugh. That's why I enjoy James and anybody debating the moon landing. Oh, that's right. It's entertaining. I got you. It's your, like, you're just unwinding. Have something to laugh at. Chill out. Be happy. Relax. I think I see. I see what you're saying. Oh my God. Batman is here. How do you know? Oh my gosh. Batman said hi. Hey, can you like my live so I can get maybe 15 likes now? Batman. Hi, I'm Batman. I thought I am Batman. I'm the born to be Batman. On a serious note, where do conspiracy theories on the moon landing come from? Oh my gosh, Doro can tell you all about that, Batman. You don't need me. I learned more about the universe listening to our friend in a few lectures than I did before. What, in the live you mean, or what do you mean? Which friend? Oh, thank you. Thank you, Steven. Well, you're always very supportive. I mean, I think you all are, just in different ways. So, Batman, Doro can tell you. The moon landing stuff started when I started to talk about the moon here. Like, from a scientific perspective, I was covering the planets and the moons and our moon and all that. And I think somebody said that they don't believe in the moon landing. And, well, Steven does, and I do. And we were covering it in terms of a totally scientific approach, but then a lot of people they just loved this debate and they wanted to fight over it. And then all the fights and debates in the chat, I was talking about you, just do not know your name. Oh, thank you. Thank you, Steven. I think I'd say that my name is Baji's mom. No conspiracy, we never landed on it. So Doro here is adding fuel to the fire. He loves it. He loves this debate. He loves the fights that happen in the chat. It's his way to relax after a day of work. And so, yeah, he can tell you about the moon landing conspiracy theory. You're in good hands, Batman. Oh my gosh. You guys. Oh my gosh, you guys. So, Steven, I just found another really nice piece of material which I might use to talk about the history of the universe. It's going to be really good. Thank you. You can call me Doro. Watch Capricorn 1. It's a movie about a fake manned landing on Mars made in the 70s. Are you serious? There's a movie on this? Watch Capricorn 1. It's a movie about a fake manned landing on Mars. On Mars? Oh, made in the 70s. Holy crap. Okay, I need to exercise. But Steven, more coming. History of the universe. Since you like the cosmology stuff, we're going to cover it again and again. And you know what? It's going to be really interesting. And I even found a little bit of material on the different models that lead to like, Big Crunch and all that type of stuff. Basically from a model perspective, like where would that happen versus what we see right now. I basically said that we currently see a flat, the evidence is pointing towards a flat universe that's dominated by dark energy. Dark energy first and then dark matter. That's a good movie. I would hate to tell you what it was inspired by. What do you mean? What was it inspired by? Tonight is gonna be fun. If you do it a little earlier, I'll pop in. I'll listen to you and watch James all at the same time. Yes, that's exactly the idea, actually. That is exactly what we will be doing. Yes, indeed. But yeah, Stephen, at some point, look at what I found. Look at this. I found all the different, I found another way of showing this, dark matter in the critical density from dark matter versus dark energy plot. So this is sort of the paradigm here. The values of omega matter and omega lambda, the best fit, that best fit the relation between M minus M and Z for type 1a supernovae. The solid and dashed lines represent two slightly different samples of supernovae. So some of the supernovae stuff that I mentioned earlier, a further look at that to figure out, like, the fact that dark energy is supported. So, yeah, okay. And see, all the constants, gravitational constant, speed of light, Planck constant, Boltzmann constant, proton mass, electron mass. Can the world be simultaneously flat and round, just like how there is wave-particle duality? Well, it's flat kind of locally. The way you experience it on the ground, close to the ground, is pretty flat, right? So in that sense, sure. What are your thoughts on the cosmos having an inherent intrinsic property known as consciousness? Stephen, you got it. Go for it, Stephen. Go for it. So I actually have to pop out for a bit. I gotta go work out and take a shower, eat something, and then I'll start my live again. Say it, Stephen, go off. Yes. Stephen, I know you're polite. You can go off. As long as you don't say any cuss words, pretty much you're good, because the curse words are filtered. Do not force me to say something I may get yelled at for. I think Batman is maybe like joking or well, asking about duality. So wave-particle duality is a very different topic than the thing that you asked, but I do agree that the flatness is relative. When you're very close to the ground, it may seem flat, but we know that the Earth is round. The Earth is not flat, it's round. Flat Earthers' heads are flat. There, I said it, sorry. Aww. Steven! That wasn't even that bad, Steven. You're so vanilla. For Steven, that's really bad. Steven has never said a bad thing on this live. Flat Earth has a flat, that's so funny. So, here's the bibliography. Stephen, I'm with you. I am with you. Stephen gets it. All right, guys. Okay, you can stay in the chat and say more things in the chat. I'm gonna get going. I need to charge the phone, get it ready for my live tonight, and then I need to like eat and stuff like that. Shower. Mainly need to shower. So I will see you soon. I will see you soon. I'm serious. What I'm trying to say is just like how there is wave-like particle duality. Is it possible that the world is round? But from another universe perspective, can we be two-dimensional? Oh. Oh. So that's interesting. Generally, people think about more dimensions being the reality, not less dimensions. That's very interesting indeed. Generally, people think about the existence. Well, I don't. I guess I don't know what I mean. It's not really generally, but generally in, say, in physics, as far as other sorts of perspectives go, and how, because I spoke about the sort of a more general theory that would include relativity, quantum mechanics, gravitation, electromagnetism. What they were thinking in that type of theory is a way to unify all of this. It's called the grand unification theory. We talked about that over the course of a few different lives and the efforts towards that. And we actually said, or we actually found that, it's an incomplete piece of work. It's still not really done. But what they were thinking there is that you might need higher dimensions, like you might actually need more than 4 dimensions, because really we have 3 spatial dimensions and the dimension of time. So the time is the 4th dimension. So I mean, there could, when we think of the Earth as a 2-dimension thing, say when we are close to the ground and we are traversing in just the 2 dimensions, then we might think of it as flat. But it's really when you, say, start to experience the 3rd spatial dimension, like you say, go up more, if you're on a flight, like an airplane, or say if you go up to the space station, then you would experience the 3rd spatial dimension. And we know it's round, right? So actually, it's interesting how you pose the question, because it's sort of the other way around, where depending on however many dimensions you experience, or we experience as human beings, we are discovering more and more truth, let's say. And pretty much we're limited to the 3 spatial dimensions and 4th dimension of time. And that's how we experience things, and that's how we understand things. But people wonder if there are actually more dimensions that we don't experience. And if we did, we would be able to unify all the different parts of physics and have a better understanding for some of these things that we don't know. You know what I mean? So yeah. Oh yeah, we can definitely talk about gravitation. So we kind of did. We actually talked about relativity over the course of a few lives. We can definitely go back to it. That sounds good. That sounds good. Okay. I will be back soon, guys. Thank you for joining, and thank you for the questions. Make sure you come